Hello everyone, my name is Li Zhang, come from Wuhan University, China. The topic of the report is an adaptive fusion of multiple InSAR tropospheric delay corrections. This report contains 5 parts. To begin with, we briefly introduce what prompted us to conduct this study. As we all know, several methods have been proposed to alleviate the tropospheric effect. These methods can generally be divided into two categories: empirical model and external data. But all these methods present unstable performances for different SAR data at different regions. Therefore, we proposed an adaptive fusion of multiple delay corrections with the purpose of improving the accuracy of tropospheric delay prediction. Firstly, we used the standard sparse steps to obtain the interferometric phase after unwrapping, and the corresponding delay phase is estimated using the tropospheric correction method. And then we used the unwrapped interferometric phase to refine it. Finally, we perform adaptive fusion of the refined atmospheric delay. The fused atmospheric delay is used for time series analysis. In this study, the tropospheric correction models we used are listed in the table. We chose the Los Angeles Basin is located in Southern California as the study area. It is adjacent to the Pacific Ocean and surrounded by mountains. The abundant water vapor makes SAR images vulnerable to the stratified delays that depend on topographic changes. The SAR data contains one stack of C-band AVSAT InSAR and two stacks of C-band Sentinel-1. This report takes the descending Sentinel-1 data as an example. We collected GPS observations as verification for the results of the InSAR time series. To evaluate the effectiveness of the fusion method, we perform statistics on the IMS residual phase after the interferometric phase is corrected by each model. As can be seen from this figure, the fluctuation tends of the IMS to be flat. 321 out of the 322 interferograms are smaller than any single correction models. Based on the interferograms generated above, we obtained the results of the mean deformation rate. There are discrepancies in the deformation rate. In figure, the black square indicates the GPS locations. A total of 125 GPS sites participated in the comparison. The RMSE of the original time series is reduced by more than 17%, with the average exceeding 30% after fusion correction. In this figure, we select 10 stations for display, and their locations are shown in the previous PPT. The gray crosses represent GPS observations. The original InSAR time series are represented by black triangles, and the time series corrected by the fusion method are represented by blue triangles. The last part are the conclusions of this study. The fusion method provides the possibility of adaptive fusion of different types of tropospheric correction methods. The adaptive fusion of the tropospheric delay can obtain more accurate tropospheric delay prediction than any single models. The fusion method can not only correct the stratified tropospheric delay, but also reduce part of the turbulent tropospheric delay. Okay, that's all. Thank you for your attention. If you are interested in my study, please leave a message to discuss.